Hi guys, good afternoon. So in the last session, we went with GRE over IPsec. Okay, so that was a route-based VPN and it was a site-to-site VPN. Now, today what we'll see is multi-site. Okay, what if you have more than one site? Okay, so when you go with the site-to-site, so the connection was point-to-point. Today, what we'll see is multi-point. Okay, so multi-point GRE, which is also known as MGR. So again, route-based VPN only. Okay, but this time it is multi-site. Okay, so a lab will look something like we are going to have ISP in between. So consider like this is your ISP. Then we will have few sites. We can call it site 1, 2, 3, 4. Okay, like this we can keep 5 sites. And all these sites, they are connected via ISP. This is your ISP. And then this is site 1. Site 2. 3, 4. And this one is site 5. Okay. Now between these sites and ISP, there will be a network that is public network. So we will consider it like, consider it 11.1.1.0/24 here. Here 12.1.1.0/24. You can consider 13.1.1.0/24. 14.1.1.0/24. And here we can consider 15.1.1.0/24. Okay. So on this side, we can keep the IP as 11.1.1.1. Here we can keep 12.1.1.2, 13.1.1.3. And then we can keep here 14.1.1.4 and 15.1.1. Like this we will keep. Okay. Then after ISP side, so all the IPs .10 we can keep. .10 here. And this is 11.1.1.10. Here we can keep 12.1.1.10, 15.1.1.10, 14.1.1. Then tunnel interface, because we are using what? Route-based VPN. So the tunnel subnet that we will use, we will use 192.168.1.0/24. So here we will use 1.1. On this side we will use 1.2, 1.3, 1.4, 1.5. Okay, then we will keep loopback as internal networks. So on each site, we will use loopbacks. So here the loopback will be 10.111/24. Here the loopback will be 10.222/24. 3/24. 4/24. And here 5/24. This is how we will keep. Okay. Now, see earlier the kind of configuration that we were doing, right? So what was the configuration? If it was site to site, so we just used to configure a tunnel interface, right? So how do we configure the tunnel interface? We will say interface channel 1. Then you'll give tunnel source, okay, as whatever the interface, let's say Z0/0. Then you used to give tunnel destination, and you used to give what here? Peer IP. Okay. This is what we used to give. Okay. That is the part we have to talk. Yeah, tunnel IP we will give here. Then we used to say IP address. Then here, whatever the IP you want to give, then after you used to give the subnet. This was the syntax. But this was in case when your peer was fixed. This time we don't have a fixed peer, right? This time we don't have a fixed peer. So that means we have to keep it dynamic. Okay. That means we cannot give a fixed. So this thing we will change here. No. If you use multiple tunnel interface, you need multiple tunnel subnets. That means what you're trying to do is that you are using one tunnel interface for site 2, one for site 3, one for site 4, and one for site 5. What if you have 100 sites? Right? Not really very scalable. Okay. So this thing we will change. We will not give a specific destination. We will say it's a multi-point. Okay. All right. So kind of we will use a command here, that is channel mode MGRE multi-point. Okay. This is the command we are going to use. Okay. Instead of destination. But remember I said that, okay, what you have to do? You have to research about NHRP. So what did you search? MGRE. Hmm. 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 That last one I don't remember. What is the use of NHRP? Correct. For mapping private to public. Then how it is different from translation? How it is different from translation? In that also you say mapping private IP with public IP. Then how it is different? How it is different? NHRP, you can say it is a mapping protocol. That is fine. And this is also okay that it is used to map private IP with public IP. But how? How is it different from? Hmm? Hmm. See, here the mapping is something like that. On site 1, I will say that if you want to reach 192.168.1.2, then use this public IP. Go to this public IP. Okay, so that means here we are not actually translating. In translation, what happened? Actual address gets changed. Here, actual address is not getting changed. Here, we are just telling that, okay, if you want to reach this subnet here, okay, if you want to reach 1.2, then send your traffic to this IP address, right? And since here we have set the source as your interface name, now this is the source interface, this is the destination. So automatically your GRE tunnel will be established between 1.1 and 1.2. This is how it is going to work. Is it clear? So here we are not changing the address. We are just telling that, okay, if you want to reach 1.2, share your traffic with 12.1.1.2. Clear? Right? Okay. This is one thing we have to do. Once we do this, our tunnel interface communication will happen. Will our loopbacks communicate? In case of MGRE, you cannot use. That is the difference between MGRE and TMVPN. Because, see here, we were having site-to-site manual configuration. MGRE, that is multi-site GRE or multi-point GRE, this is a static way of configuration. This is what? Static way. Here, you have to give a mapping for every single site. That means, let's say on site 1 you are configuring. So here you will say that IP MHRP map, and then if you want to reach 1.2, then share your traffic with 12.1.1.2. This kind of command you will give. Is it clear? Okay. In the tunnel interface only we have to give. Okay, because tunnel interface we are saying, first of all, that tunnel mode is what? Multi-point. Then we will use a network ID, IP NHRP network ID, and a random number we will use. And after that, we will give these mappings. So, yes, yes. That is the problem with MGRE. That if I have 100 sites, so on site 1, first of all, I'll give this mapping. Then I have to say that if you want to go to 1.3, share your traffic with 13.3. If you want to go to 1.4, share with this. Yeah. Now, same mappings I have to give, not same, but similar kind of mapping I have to give on the site 2 for all these sites, on the site 3 for all these sites. So that means everywhere I have to go and manually map all the sites. Now imagine you have 100 sites, right? Not a practical solution, and it's not a scalable also. Anytime one of the site is going down, you want to close a branch. Now what? Remove all the mappings. If you want to add a new site, go to each and every site and add the mapping. Not a very scalable solution. Very complex. Correct? So here we have a problem. This problem is solved where? In the DMVPN. Okay. And for this loopback communication, you will have to give a static route for every single site. Yes. So that means on site 1, how many routes I have to configure? 1, 2, 3, and 4. Okay. What are the 4 routes? One for this site, another one for this site, another one for this site, another one for this site. Same way on the site 2, I have to configure this site, this site, this site. No. MGRE. DMVPN will do all of these things automatically. See here. How many routes? Yeah, mesh topology kind of, you can see. Okay. So everywhere you have to go and configure these routes. Okay. Like this. And then this site is there. So many routes. Okay. So these are the problems with the MGRE. And this is where your DM VPN comes in. Is that clear? Now, let's go and practically implement this. Create a new lab, call it MGRE. So 5 sites and one ISP. So total 6 routers will fit. Okay, this will be our 5 sites. So here we will need 5 interfaces, and by default router comes with 4. So I will increase it to 6. Let's power up all the devices. So here we will use 11110/24 on this side. Well, here we'll use 13, 14, 15, 1, 12, 13, 113, 14, 114, 15, 115. One, 110, 12, 110. And this will be 13, 110, 14, 15. This will be 50. Then the tunnel subnet that we are going to use. Tunnel subnet will be 1.0/24. So here the tunnel IP will be 1.1. Then it will be 1.2, 1.3, 1.4, 1.5. Now loopbacks. One on one slash 24. Three dot three. And then here it will be 4.4.4. This will be 5.5.3. Okay. Now, first of all, basic configuration. Who wants to do? Hmm? Mhm. Mhm. Leave it, not tunnel right now, just loopbacks. Where? That is loopback.
No new getting loopback enter.
Basic configurations always remain same. Even VPN configuration also slightly changed.
I don't have no, so that if I have, then I will put
You can ask. Let's be. So far configurations everybody understood, right? Great. Now let's bring up all the devices. Site 1, Site 2, Site 3, 4, 5, then ISP. This is Site 1. Site 2. Now, once we do this basic configuration, public to public communication should be there. Copy. Then we have ISPs 11, 12, 13, 14, 15. Now, first of all, we will test public to public communication. So I'll say ping 12.1.1.2. Communication is there. 13.1.1.3. Communication is there. 14.1.1.4. Communication is there. 1.1.5. Communication is there. That means basic configuration all good. Now, after this basic configuration, the first thing we do is what? We configure tunnel interfaces. Okay. So let's call it configure MGRE tunnel interfaces. First of all, site 1. Okay. Now let me first show you here. Now what will configure tunnel interfaces? So I'll say interface tunnel 1. Okay. Then I used to say tunnel source is what? Either you say 11.1.1.1 or we can say interface Z0/0. Both are fine. Okay. Where? Which private IP? This is a public IP, right?
Yeah, so this
So-
public IP is dynamic.
No. This is not dynamic. Okay. This is not dynamic. This is a fixed type. Okay. So you can say 11.1.1.1 or you can give this interface. Okay, both are fine. So anything we can give, let's say Z0 by 7. Now destination we will not give. Okay, so we will say turn on mode GRE multiply. This is the command we will give. As soon as I give this command, my tunnel interface will come up. Remember, when we give source and destination, our tunnel should come up. Okay. Then I can assign IP address on this tunnel. IP address. Sorry. Yes. 168.1.1. Okay. 255, 255, 255, zip. This is done. So what did I do here? I said interface tunnel 1. Tunnel mode GRE multiple. Point. This is okay. Then I configure IP address 1.1. Okay. Copy this for other sites. For site 2, what we will change is only IP. Site 3, 1.3. Site 4, 1.4. Site 5, 1.3. This is clear. Now let's copy. Yeah, so copy, copy, copy. Done. And you will see that everywhere my tunnel interface is up. Correct? So let me try to ping my tunnel interface. If I say ping 192.168.1.2, I'm not able to ping. Why I'm not able to ping? Sorry. Route? We don't require a route. See here. You show IP interface. Sorry. Show IP interface. Wait. My tunnel is configured. Everything is up. And if I check show IP route, okay, and you can see to reach 1.0 network. Hmm? No, ISP, how can we control the ISP? I cannot ask the ISP to configure MGRE for me, right? Here, the thing is that NHRP mapping, that will be required. Because I need to say that, see, I know that I can communicate to this network using the tunnel interface. I can communicate with this network using the tunnel interface. But if I want to go with, let's say, for example, if I try to send this packet also, okay, let's go do one thing. Let's capture the ISP. Okay, debug IP, ICMP, and do debug. Let me try to ping again. Is there anything on the ISP? No, nothing is there. Let me enable debugging here. Debug IP, ICMP. right? Okay. Maybe ICMP here right now we are not able to see. So let me say debug IP packet. See here what it says. Encapsulation. Okay. Tunnel is not getting established. The tunnel is not getting established. Why? Because when I try to establish a tunnel with this, I don't know how to go. Because always a fixed destination will be required, right? Fixed destination will be required that if I want to reach this, where I send the packet. And this is where your MHRP will come in picture. Okay. So what you will do here, you will configure MHRP. How you will configure it? First of all, go to the tunnel interface. Interface tunnel 1. Then say IP NHRP, network ID, and an identifier you have to give. This is local, doesn't have to be same on all the routers. Okay, or all the sites. Let's say 10, hit enter. Done. Then you will say IP NHRP map. Okay, then what we will give? Destination IP address. So my destination IP address is 1.2. Then what I have to give? I have to give that means the actual IP address that I'm trying to reach. Okay, so which is 12.1.1. Done. Now if I try, let's see, and also let me debug here. Because earlier encapsulation was failing at site 1 on. Debug IP packet. Now see. Blueprint 192.168.1.2. My packets are this time reaching site 2. See here. But on the site 2, what is happening? Because here we don't have the mapping. Here we don't have the mapping. So here encapsulation is failing now. So same mapping I have to do here also. Right? So let me configure it. Interface, tunnel 1, IP, MHRP, network ID, anything you can give, IP, MHRP map, and if you want to reach 1.1, send the packets to 11.1.1. Now let's try. We have the communication, and this time no encapsulation failure issue. Clear? Yeah, local. Now, same way from site 1, if I want to communicate with site 3, I need mapping. Same with site 4 and same with site 5 also. So what I have to do? I have to say configure MHRP for tunnel interface communication. So what I'll do here? Site 1 interface tunnel 1 IP MHRP network ID 10 IP MHRP map 192.168.1.2 12.1.1. Then I will say IP MHRP map 192.168.1.3 and map it with 13.1.1. IP MHRP map 192.168.1.4 map it with 14.1.1.4. IP MHRP map 192.168.1.5, map it with 15.115. Same thing we will do everywhere. Okay. So here, this will change to remaining everything will remain same. This is site 3. This will become 1. Site 4. This will be site number 5. This is clear. Okay. Site 1. Copy. Paste. Site 2. Copy. Paste. Site 3. Copy. Paste. Site 4. Copy. Paste. Site 5. Copy and paste. Done. Now let's check the communication. Blueprint 192.168.1.2 able to communicate 1.3, 1.4. Right. Now if I test the communication with the loopback, 10.2.2.2 undeliverable. How do I reach? See here. Do debug IP packets. Check what is the problem. Right. Okay, here it's not mentioning the error. It's just showing this code. Okay, so basically it doesn't have a route. That means the packet is undeliverable. Okay, we can check also. We can say, see, this packet is right now being dropped where? Oh. From site 1, I'm sending the packet. Site 1 will use source IP as what? See here. My source IP is fine. That means it is being dropped at my ISP. ISP will say, I don't have a route. See here, if I debug on ISP, because that's why it's not showing here, right? If I say debug IP packet, let's go with the packet. Now see here, if I send it again. See here, what it says. My ISP is saying the packet is unroutable, right? Like the kind of response we get, destination host unreachable. Okay, so my ISP is telling me that this packet is unroutable. And this is the reason what I'm getting here. The answer I'm getting as, okay, see here. My ISP is telling me that this packet is not routable. Okay. Now, what we need to do? Routes we need to configure, and route I need to configure via tunnel. Because right now, if I check my routing table, so my routing table says that I can reach the 10.1.1 network only. and any other network I want to reach, I will send it to the ISP, and ISP will say, I will not allow any private network. Correct? So what I need to say that if you want to reach 10.222, then you have to go via tunnel, that is 1.2, right? My tunnel IP on the second site is what? 1.2. Then automatically this will be resolved to 12.12.112. Yes, always. Next stop will be what? Your destination tunnel. Okay. So I'll configure here. I'll say, now right now, if I show you that whether my packets are reaching here or not, do debug IP. So already I show you that ISP is dropping it. So right now, this packet is not even going to site 2. But now what I'll do, now here I'll say IP route. If you want to reach 10.220, then go via 192.168.1.2. And now if I try to ping, you will see that on site 2, I will get the packets. On site 2, I'm getting the packet. Why not send? Reply will be sent. Why? Because here right now my source IP was what? My tunnel interface IP. If I ping like this, if I say to ping, exactly. If I say source as 10.1.1, because right now when I ping from here, it used that it is so that how it will go? It will go via this. So source IP it used what? My tunnel interface IP. 1.1. So 1.1 already reachable. That's why I got the response, and you can verify here. The response was sent to whom? 1.1. So yes, now the packets will drop here because I'm using the source as 10.1.1.1. So my packet is going to the ISP, but ISP, see, sorry, site 2 is going, site 2 will also respond without any problem, but this guy will drop it. Okay, see here. Let's try to ping again. This guy will send a response. This guy says, I'm routed. Okay. So what we have to do, we have to give a route here also. So I'll say that IP route, if you want to reach 10.1.1.1, 255, oh sorry, 10.1.1.0, entire network I'm talking about. Then use 192.168.1.1. Now ping. Without any problem, this time ISP will not even come to no communication happening. Nothing on the ISP. Why? Because this time my traffic is entire traffic passing through the tunnel. This is clear. So same way we have to give routes. So you will say configure traffic routes. Now imagine you have 100 destinations, 100 sites, right? For loop back communication. So on site 1, you will say IP route 10.2.2.0, 255.256.250, 192.168.1.2. This will be 1.3, 2.3. This will be 1.4, 4.4. This will be 1.5. This will be 5.5. on site 2. One dot one. This will be dot one. On site 3. This one will be 1.1. This will be dot one. Site 4. One dot one. This will be site 5. 1.1. This will be 1 dot. Let's copy next. Copy. Site 1. Copy. Site 2. Copy. Site 3. Copy. Site 4. Copy here. Site 5. Now see 10.2.2.2 able to ping 3.3.3 able to ping 4.4.4 able to ping 5.5.5 able to ping. We got the communication. Now tell me, is this communication secure? No. So what we need to use? IPsec. Okay, so we can use here IPsec security. Okay. So next is what? Configure IPsec for securing the ping. So what do you say? Crypto, ISACM, policy 10, matching SHA-256, authentication, reshare, group number 14, encryption will use VS, lifetime we can use 56, 400. Then ISACM key. Now here address we have to use. Default. Okay, so we can use here the keyword address we have to use. This means anybody. Peer address is anybody. Then IPsec transform set ESET, then ESP AES, ESP SHA-256 HMO. And for reducing the header, we can use transport mode. Okay. Then after crypto, this time we will create profile. And let's call it VPN profile. Okay. And here we'll say set transform set. ESET we want to use. Then we'll say interface channel 1. Right. Interface channel 1. And we'll say channel protection. IPsec profile. Name is what? This is the profile. Now this is the same configuration you do on all the sites. Okay. Copy this. All sites. Site 1 as a camp on, site 2 as a camp on, site 3 as a camp on, site 4 as a camp is on, site 5 also as a camp is on. Okay. Now let's capture the packets and see whether the communication is being secured or not. Okay. So ping 10.2.2.2 source and the 1.1.1. Let's see. Do you see the packets traveling are what? ESP. Okay. So that means the communication is secure. Now under ESP also right now we will have what? That GRE header also. So to remove the GRE header, we'll use one more command here. For SVTA, right? Kernel mode, IPsec, activity. This will be our SVTA configuration. Okay. So this configuration, we will do it on all the sites. So let me copy. Okay. And these are all the informational messages. Now go on site 1. Let's say do here get to session, and then I can try to ping again. See some optical void. Not about that. Actually, it says the packets are going to ISP. Will show towards the route. Tunnel interface is down. Okay. If I run SP here, line protocol on the tunnel is down. I think we have to shut down and shut down the tunnel interface. Sometimes these kind of issues will happen. Okay, right now I'm using SVTA and I'll say interface tunnel 1 shutdown. No shutdown. Mhm. Amp is off. Mhm. It's not about that much. Everywhere is a campus off. So run interface tunnel 1. Tunnel source is fine. That command is not the right. Tunnel mode GRE multi-point. Okay. We cannot change this mode because when I change it to IPsec IP4, the multi-point is removed. Okay. So we have to use this one. SVK we cannot use in this mode. But this command will not be there. Now you will see everything will come back up again. See, Isaac amp is on. Okay. And since Isaac amp is on, you can see all the main mode messages, all the quick mode messages. Hmm? Yeah, that will not be removed because this is multi-point GRE only, specifically. So we cannot remove it. 20 bytes we remove using transport mode, 4 bytes we cannot remove. Okay, and now if I check the show IP route, we can see our tunnel interface and all our routes. And now we can ping also. We ping 10.2.2.2 source as 10.1.1. This is clear. So this is your MGRE. Okay. Now use SVTA here. Okay. So this is your MGRE configuration with IPsec. MGRE with IPsec. Clear? Any doubts? Now tomorrow we'll see about DMVPN. Okay. So for DMVPN, one you have already researched. The problem you have already understood here that everything is static here. Okay. So in DMVPN, everything will become dynamic. We don't have to do this much of config. Obviously, configuration will be there. But after that, when we make changes, then after there is no configuration. So next is what we have to check about DMVPN. You have to see about hub. What is a hub? What is a spoke? Okay. NHRP you have already seen. So again, research about it, NHS, and then do it. These all things is your task for today. You have to search about all these things. Online people, any doubt? This is clear. So this is it for the day. We'll see you tomorrow with DM VPN. All right, guys. See you tomorrow. Have a good day. Bye.